All right, so now we're going to work on actually just graphing a quadratic function in standard form. The key features that we are going to find, we're going to find the vertex, we're going to find the axis of symmetry, we want the y-intercept, and then we want the, what do we want to call it? The A pattern values. I just made that up. What is our A pattern? The 1, 3, 5, does that change from a 1, 3, 5? Okay. So to find the vertex, we just learned in the last video that there's a little formula. The h value is equal to negative b over 2a. So looking at our equation, let's identify our a value is the number in front of x squared, which is 1. Our b value is in front of the x, which is negative 4. And our c value is a positive 8, that number on the end. So let's plug in our b value. We have a negative parentheses. Then we plug in our b value, which is negative 4, over 2 times a, which is 1. So a negative 4 turns positive over 2, and we get half of our vertex. The h value is a positive 2. How do you get the k or the y value? Well, we're just going to plug in a 2 for all the x's. So the k value is the y value, which is just plug in a 2 for x's, so 2 squared minus 4 times 2 plus 8. 2 squared is positive 4. Negative 4 times 2 is negative 8 plus 8, and 4 minus 8 plus 8 is 4. So we have a vertex of 2, 4. We can go to our graph and plot that ordered pair, 2, 4. So if we go over 2, up 4, we've got our vertex. All right, axis of symmetry. Axis of symmetry is just x equals, and it's the x value of your vertex. X equals 2. We can see it's right there, so it's that vertical line that's going to go through the center of your graph. If we go to our graph and plot or draw in our axis of symmetry, it's just this vertical line right there that goes through your vertex at x equals 2. All right, next we have a y-intercept. How do you find a y-intercept? Well, we find a y-intercept by plugging in a 0 for all the x's. So y equals 0 squared minus 4 times 0 plus 8. So we have 0 minus 0 plus 8. We have a y-intercept of positive 8. That will be an ordered pair. The x was a 0, the y-intercept was an 8. We can go to our graph and we can plot the y-intercept at positive 8. All right, once you get that y-intercept on there, because these graphs are symmetrical, do you see how it's 1, 2 away from our axis of symmetry? I know it's going to have a reflected point, 1, 2, to the other side of that. So that's giving me another point that we can plot on our parabola. All right, the last thing we want to look at is our a value, and what kind of pattern will that give us for the rest of our points. So our a value is equal to 1. Because that's positive, that means that our parabola is going to open up. And then we're going to do our 1, 3, 5 pattern. So you take your a value, you multiply it by 1, you multiply it by 3, and you multiply it by 5. So we get a 1, 3, 5 pattern. This is the one we've seen a lot of. So from our vertex, we're going to go up 1 to the right 1, plot a point. From there, up 3 to the right 1, and that point we already have plotted, and then we're off our graph. So we'll get the point on the other side, go back to the vertex, go up 1 to the left 1. There's a point. Up 3 to the left 1 is that y-intercept that we already plotted. So now we just draw in our parabola. We have a lot of nice accurate points. So we can get a very nice looking parabola like that.